class we are going to discuss bubble sort. Um, so l- Let me explain to you what exactly is bubble sort through an example. Consider an array of integers where the elements are not arranged in the order of their values. So say first element is 8, the second element is 4, the third element is 5, the fourth element is 3, and the fifth element is 2. Now in bubble sort what happens is, after the array actually undergoes various scans from left to right, and after each scan the initial unsorted array um, bubbles the uh, bubbles the maximum element to the very right of that unsorted array, and thereby the size of the sorted part keeps on of that array keeps on increasing, and the size of the unsorted part keeps on decreasing. Say for this particular example which we are considering, initially the if you can notice the whole array is unsorted. Okay, after the first scan of this unsorted array using bubble sort, the array becomes 4, 5, 3, 2, 8. So what happens is the sorted part of the array after the first scan increases in length to 1, and the unsorted part of the array decreases in length to 4, right? um, so uh, like if we keep on increasing keep on repeating this process, and now we scan the unsorted part again and bubble the maximum element which is 5 to its appropriate position. The what keeps on happening is the sorted part of the array keeps on increasing, and the unsorted part of the array keeps on decreasing in length, and at the very end the whole array ends up being sorted. Okay, so let me explain to you this sorting mechanism in further details by going through the same example, right? So initially the array is 8, 4, 5, 3, 2. Okay, so let us consider the pass one. Okay, pass 2, or say scan or pass whatever, pass 3, and pass 4. So in pass 1 we start with this array 4, 5, 3, 2. The whole array is unsorted. We compare the first element integer with the second integer. Here 8 is compared with 4, 8 is greater than 4, so what happens is 4 is bubbled to the first position and 8 is bubbled to the second position. Next 8 is compared with 5, 8 is greater than 5, so 5 is bubbled to the second position and 8 is bubbled to the third position. Next 8 is compared with 3, 8 is greater than 3, so the 3 is bubbled to the third position, 8 is bubbled to fourth position. 8 is bubbled compared with 2, 8 is greater than 2 as well, so 8 is bubbled to the fifth position, 2 is bubbled to the fourth position. So what ends up happening after the first pass is the initial unsorted array get divided into two parts, unsorted and sorted, right? And what ends up happening is the maximum element in the unsorted array ends up being bubbled to its correct position. Now let us consider the pass 2. So we start with this array now, 4, 5, 3, 2, 8. The array is now basically has two parts, one is unsorted and one is sorted. We only need to consider the unsorted parts, so what we do is we compare 4 to 5 for it's in its correct positions. So this remains this, and we compare 5 to 3, 5 is greater than 3, so 5 is bubbled to the third position, 3 is bubbled to the second position. 5 is compared to 2 now, 5 is greater than 2, so 2 is bubbled to third position, 5 is bubbled to fourth position. Now because we only scan the unsorted part, we need not compare 5 with 8, and after the scan what ends up happening is the unsorted part further reduces in length to 3 and the sorted part increases in length to 2. Right, now let us consider the third scan. 4, 3, 2, 5, 8. 4 is compared to 3, 4 is greater than 3, so 3 comes in the first position, 4 goes to second position. Now 4 is compared to 2, 4 is greater than 2, so 4 comes in third position, second goes in 2 goes in second position. So if you see now, after now we need not compare 4 with 5 because we only are concerned with the unsorted portion. So now after the past 3, unsorted portion reduces in length further and sorted portion increases in length. And in pass 4 we compare 3, we start with 3, 2, 4, 5, 8. We compare 3 to 2, 3 is greater than 2, so 2 comes in first position and 3 comes in second position. And we need not compare 3 with 4, so basically after this pass what happens is now because in the unsorted part only one element is left, so the whole array becomes sorted. So this is what exactly happens in bubble sort. Basically after each pass or scan, the maximum element in the array actually the maximum element in the unsorted array arrives at a correct position, which is basically end of that unsorted portion, and thereby increasing the length of the sorted portion and decreasing length of the unsorted portion. Right, so this is what bubble sorted is. Now let us consider how let us see how are we going to implement it. Skeleton bubble sort class ready in front of us, so we are going to implement a method in this class. Let us name that method bubble sort. What that method does is it accepts an integer array, sorts it and modifies the array and returns it in the sorted order. So basically now we are going to implement the method bubble sort. This accepts an array A, and so what the method does is it basically sorts the incoming array using bubble sort. Right. Now if you would recall, bubble sorts terminates when the length of the unsorted portion of the array is 1, right? So that becomes our terminating condition. Initially the length of the unsorted portion of the array is unsorted array length or unsorted part length. Let us name it unsorted. Initially the length of the unsorted part would be same as the length of the array, right? So our incoming so our terminating conditions becomes if unsorted part length is greater than 1, then basically keep on bubble sorting it, else return, right? So in each pass, so this is basically let me comment here as well. Sorting ends when the length of unsorted portion is 1. Now in each pass, what happens is we scan the array from left to right, and basically left to the length of the unsorted array, and we keep on bubbling the maximum element encountered till far to the right, right? So um, bubble, keep on bubbling the maximum element in unsorted part to the right. So the unsorted part length, let me copy this, okay, plus I notation num1 equal to, one thing to notice here is it should not be unsorted part length, but it should be unsorted part length minus 1. Why? Because if you would recall, we swap, we basically, if we are scanning the current element, we scan the current, we read the current element, we read the next element to it, right? And the last element, that is the element at unsorted part length minus 1, would actually be the last element, right? So there will be no element next to it, right? So, and the condition would basically the array, it would error out, right? So we need to basically go till unsorted part length minus 1, and we retrieve the element at I, and we retrieve the element at I plus 1. Okay, now what we do is we compare if again we compare num1 with num2, and what exactly we need to do is, with num1 is, if num1, not while, if num1 is basically greater than num2, then we need to bubble num1 to the num2 position, and we need to bubble num2 to num1's position, right? So ai plus 1 becomes num2 num1, and ai becomes num2. Okay, and this keeps on happening. So we do it till unsorted part length minus 1, and we keep on bubbling. So after this pass, what happens is, in the unsorted part, the maximum element in the sorted part bubbles to the last index of the unsorted part. Okay, and so, and the sorted part length increases, thereby decreasing unsorted part length. So we say unsorted part length decreases. Okay, and after this, so once this terminates, what will happen is, the array, when the call will return, the array will be sorted, right? So for to let us consider, let us give the same array which we took as the input, which we took for the example as the input to this method. Okay, so the array A is 8, 4, 5, 3, 2. Okay, and next what we do is we call bubble sort on this array, bubble sort A, and we print that array. So so after calling bubble sort, the array should now be sorted. So arrays dot to string A, and let us print it, system dot out dot println. Right. Let us check if everything is fine. Unsorted part length equal to a dot length. Unsorted part length is greater than 1 while this is greater. So keep on basically bubbling the last the maximum element in the sorted part to the last, and yep, so this should work. Let us try compiling it. Okay, 2 3 5 4 4 5 okay, so this works, but I can think of one optimization that we can do here. uh, I will give you guys some time to think of that optimization. So basically pause the video at your end, and if say try to think for the optimization for like 2 minutes, and if you can figure it out, good. If not, then yes, let us discuss the optimization. Please pause the video now. Optimization can we do here? Let us consider an array. um, the array we are going to consider is basically uh, almost already sorted. Say the array is 4, and then the element is 5, and the 6 7 7 9 and 8, right? So after the first pass, the array, though it's almost sorted, it's not sorted as of now, right? So after the first pass, what happens is the maximum element gets bubbled to the last. Okay, so the new array becomes 5 7 8 and 9. Okay, now if you would see, the array is sorted now, and if in another scan of the array, no bubbling happens because 4 will be compared to 5. No, you need not bubble. 5 will be compared to 7. You need not bubble. 7 will be compared to 8. No bubbling needs to be done. And 9, we already know it's sorted. So we can conclude that if in a new scan, if new pass, no bubbling happens, that means that whole array has been sorted. So we can use that here to our advantage, and uh, reduce the uh, reduce the number of scans here. Okay, so let us do that. um, so we will modify the while condition to not only take into account that the unsorted part length is greater than 1. We can also terminate it if no bubbling happens in the previous scan, right? So let us take a boolean called bubbling occurred and set it to true initially. So basically what will happen is sorting ends when the length of the unsorted portion is 1, or no bubbling happened in the previous part, or occurred. So now how can we know that bubbling occurred? If say we enter here, we basically enter this this condition, we know that the bubbling happened, right? So initially we can assume that no bubbling happened. Bubbling, initially we can assume that no bubbling occurred. So bubbling occurred equal to false initially. It becomes true only if it enters here, right? So bubbling occurred equal to true. So this particular condition now avoids the loop. Sorry, I basically mistakenly renamed it as bobbling instead of bubbling. So rename it now. Okay. So now what would happen is bubbling occurred is true initially, so it enters the while loop, and unsorted part length is greater than 1. It enters if the array obviously has length greater than 1. It will enter. It will see, okay, as of now no swapping happened. The first time it entered, no swapping happened, so it says bubbling occurred is false. As soon as a swapping happens or bubbling happens, it says bubbling occurred equal to true. So in a scan, in a pass where no bubbling happened, bubbling occurred will remain to be false, continue to be false, and the loop will exit from here, right? In which case we would know that the array is already sorted and we need not scan the array again. Okay, so let us try this. So this is basically a new example. Let's see which is okay. Yeah, so this is the input array now, 24732, and the output array is already sorted, right? 22347. We can try with other examples as well. So let us try with other examples. Maybe 24, the one something like 2498, right? Okay, so scan. So this is sorted. It's good. And if you want to so basically we avoided scanning the array again, because the first time it entered the pass, right? The array, the first time it entered, initially the array was 24798. After the first pass, the array became 24789. It will go another pass, but after the second pass, what would happen is it would recognize, oh, no swapping happened, right? And in which case it would avoid the subsequent pass. So the pass 1, pass 2, right? And after that it will stop going inside the while loop here, right? So it will avoid it. So it will avoid any more scanning of the array. Yeah, now let us calculate the time and space complexity of this implementation. So if you can see, in the worst case scenario, what would happen is the array would be sorted but in decreasing order. Okay, so what would happen is basically initially, let's say the array would be 98765, right? So in this case, a 9 would initially move to the last one. So 87659, and it will keep on happening. So there will be, in worst case, how many passes? Order of n minus 1. Okay, where n is the length of the array. Okay, and in each scan, what would happen is basically we are scanning each of the 5 elements. So in the first pass, basically we are scanning 4 elements, 1 2 3 4, right? So 4. In the second pass we are scanning 3 elements. In the third pass we are scanning 2 elements. In the fourth part we are scanning 1 element. So total is basically n minus 1. So the time complexity of the algorithm is n minus 1 plus n minus 2 and so on up to 1. Okay, which is nothing but if you can see, this is basically n minus of 1, n into n minus of 1 by 2, right? So that is the time complexity, which basically is n square by 2. Okay, so that is the worst case time complexity. What happens in an average case, right? In an average case, we can assume in an average case, what would happen is say the scanning, for each scan as such, we still need to go through till the end of the unsorted part, but the scanning will stop somewhere in between, right? So n minus 1 scans. Okay, so let us consider an average case. In average case, what would happen is the scanning will stop in between, so n minus 1 and so on up to say n minus of 1 by 2, right? um, which is still same as order of n square. Okay, so even in the average case, the time complexity is order of n square. Okay, now consider the best case where the array is already sorted. Okay, say the array is 2, 3, 4, 5 and 8. In this particular case, as the array is already sorted, we will, in the first scan, we will compare 2 to 3, there no bubbling happens, 3 to 4 no bubbling happens, 4 to 5 no bubbling happens, and 5 to 8 no bubbling happens. So we just go inside once, okay, and scan the array once. So like we scan each element though, right? So the time complexity in the best case is order of n. Okay, now this is about the time complexity. So let us write, say, worst case time complexity and best case time complexity. So time, okay, so worst case is order of n square for bubble sort, and the best case is order of n. Okay, now let us consider the space complexity. Are we actually taking any extra space here? Except this, except say this constant space here and here, we are not taking any extra space, right? So or maybe defining these booleans. So the space complexity in both the worst as well as best cases order of 1. So this is basically the space and time complexity of a worst space and time complexity of bubble sort. Yep, so you need to remember this, otherwise it's basically, so you basically need to remember these results. But as such, in the interviews, you would rarely be asked to implement bubble sort, right? So yep, I will also provide you the source code in the git repository. That's it for this session. In the next session, we will learn about insertion sort. Thank you.